everyone, I'm Yichi, a member of the SGLang open source community. Today I'm going to introduce SGLang Diffusion, an open source inference engine for image and video generation. Its goal is to push diffusion model to a new level of performance while staying open source and highly flexible. In the next few slides, I'll walk through its positioning, core capabilities, performance numbers, and some generation examples. So first, let's talk about what SGLang Diffusion is. So under a fully open source setup, it greatly speeds up the inference for text-to-image, text-to-video diffusion model, and also we support image-to-image and image-to-videos, of course. So for developers, it means on the same hardware with the same models, images and video can be generated much faster. In short, SGLang Diffusion is bringing a truly practical acceleration revolution to image and video generation. First, about the functionality, SGLang Diffusion is a unified inference engine built by the SGLang team, and by porting our scheduling and kernel-level optimization from LLM serving to diffusion model. So it's not just a single model, but a high-performance runtime dedicated to diffusion-based models. And for now, we already support a lot of major open source models, and it converts text to image, image to image, and text to videos, which fits a lot of the most recent real-world needs. And for the interfaces, SGLang Diffusion also offers an open source compatible API, CLI, and Python bindings. With almost no extra learning costs, developer can smoothly move from the local experience to productions. And I guess most of you guys are more interested in the performance. So let's talk about the performance comparison. So on the chart on the right, we compare the SGLang Diffusion with Hugging Face Diffusers. Under the same hardware and model setting, the SGLang Diffusion delivers about 1.2 times speed up on average, and at most, it provides up to 5.9, nearly 6 times faster in the best cases. So that's very meaningful gain for the production system. And on the bottom chart, after enabling the CFG parallel and the USP multi-GPU parallelism, the SGLang Diffusion gets additional speed up in multiple GPU scenarios. So this means that when we need to generate image or videos at scale, we can use our cluster resources much more efficiently and further cut the inference latency, which is pretty meaningful. So, all right, next let's take a look at some of the generation results from the SGLang Diffusion. So this slide, we show some samples from the text to video and text to image. So on the top example, you can see that we simply write one prompt in the command line and generate short videos. So the prompt is a curious raccoon, and here I'll play the video to show you guys the results. Okay, and for the same prompt, and if we switch to another model like one image, and we want to generate an image on the bottom, we can see there's a text-to-image support. And the same prompt, we can see here is a high-resolution image being generated by the SGLang Diffusion. All right, next let's take a look at some generation result for the image-to-image and image-to-videos. So for image-to-image, we can keep the main subject of the original image and use prompt to change the styles, lighting, or overall mood. So you can see here we have an animated style like 2D image here, and after we prompting the image, like we want to change the style, and it turns to be a 3D kind of like cartoon style image. And for the image to video, we can animate a still image and turn it into a short video clip, as shown like this. So all of those samples you can find in our official website and the official tech blog. So yeah, feel free to check out on that. All right, on the last slide, we'll move right into the live demos. I'll briefly show how to start SGLang Diffusion, load an open source model, and use simple command line call to generate images and videos. All right, let's jump right in. So right now I'm going to show you how to use the SGLang Diffusion on the Google Colab runtime environment. And in the runtime, we are using an A100 GPU card. And first of all, definitely we have to import the SGLang Diffusion. So for demo purpose, I already got it. And I want to import the models as well. And right now we're using a one AI for as the diffuser model, and it's an open source model as well. Yeah, and we want to run this command. This command will help us to generate the text to video result. And I'm gonna show you. Let's try it out. Okay, so currently this cell is running, and we have to probably wait for a few minutes to let the model to generate the result that we want. So yeah, let's patiently wait for a few minutes.
A few moments later.
All right, looks like the result is generated and the running is completed. So let's, here's the script I entered to show the result. So previously we saved the result as a file in this file system. So let's show it. Yep, so as we can see, the result is already there. Because we entered the same prompt, a curious raccoon, as the demo. So we can see the result is same as the sample result as we previously showed in the slide. And if we want to give AI a more challenging problem, for example, something that is like purely imaginary and not in reality, for example, a cyber city, skylight at night and flying cars, new rains. So those are pure imaginary scenario. So it will make it harder to generate. So let's try this one.
Imagination.
Okay, so this one is completed as well. So let's run this script to show the latest generated videos. All right, looks like it's something, right? The video is generated and it matched the prompt that we entered and it looks super cool. That's it for the demo. Hey everyone, welcome back. Hope the previous demo was helpful to you. And in the end, we want to give a great shout out to every engineer from the SGLang Diffusion team and the Face Video team for a lot of effort to put in and make this happen. And also, we want to thank NVIDIA and Voltage Park for providing compute resources that made this experiment and optimization possible. So, if you also would like to dive deeper into the technical details, please check out the original tech blog link on the slide. That's it for today's video. Hope this one is helpful, and thanks everyone for watching this.